back to Harshit Academy. So today we're going to discuss about class 9 chemistry NCERT and some foundation subject or concepts also included in this video. So first lesson is matter around us. So it is a very interesting chapter. You can learn with me in a simpler and conceptual way, because here you have to understand what is the concept. So conceptual understanding is very important in science subject. So let's start our lesson. The lesson is matter in our surroundings. So firstly here what we have to understand, what do you mean by matter? So matter, I will write definition first. Matter is anything in the universe, in the universe which has a mass and occupies some space. So what I will tell you is, so the matter is anything in the universe. It is the thing which is anything in the universe which has some mass. Mass is nothing but weight. Weight of an object, we call it as mass, and occupies some space. Means that object which has some mass, which has some tiny or little amount of mass, and it occupies some space. It occupies some space. For example, if I take an object, if I take a ball, for example, this ball which has some at least a tiny amount of mass, it would be have. Example, we have 2 grams of weight it have, and it compulsorily occupies a object or a material which has some mass, it definitely occupies some space. So this object ball is also occupied in this space. If this is a table, this much of space is occupied. This much of space is occupied by this ball. Means it is a material. So if we consider this as a matter. Alright. So now in this lesson, what the subtopics we are learning is, firstly, the physical nature of matter. Physical nature of matter. So if we talk about what is the physical nature of a matter, in ancient days, the ancient philosophers divided mass in different states like water, like that. But now the scientists newly updated and divide this physical nature of matter into 3 states, into and physical and like substances like those. But we can talk it about later. But what we are discussing is the physical nature of matter. Means what is the physical nature? First point is, this matter, which is this matter, is made up of tiny particles. Tiny particles. Okay, for example, if we take this ball, if I take the surface of this ball, clearly observe guys, if I take a small piece, if I cut this edge, a small piece, I am taking that small piece and I zoom it. If you take a microscope, for example, but I am zooming it. Note this point in your mind that, and if I zoom that piece, it had some little amount of particles. We can't observe. Actually, we can't observe that particles. Like if you compare it, like in biology, you heard about cell like that. It's a unit. What are these particles? Are a tiny unit, not cells. It's a tiny unit. So these particles, all right, this material made up of tiny particles. These are so tiny, all right, and matter is made up of tiny particles. Particles of matter is very small. These particles are very small. These 2 points we have to note under the physical nature of matter. All right. So now let's see the characteristics of matter. Next is characteristics. Of matter. Alright, characteristics of matter. Characteristics are mainly 3. Note it down because these are very important. Mainly 3 characteristics it would have. Firstly, first characteristic is the particles of matter have spaces between them. The first point here, they have had spaces between particles is there, and next one is they are continuously moving. They are continuously moving. And the third characteristic is attraction is being takes place among particles. I will explain clearly later. So attraction. So these three are very very important places: moving and attraction. So if you consider these are the particles of matter, so what is spaces between them? They are not combined each other. If we take these particles, 1, 2, 3, 4, 5, 6, we observe some spaces. This is a space. So we observe these are the particles of matter. We can observe some spaces among particles of matter. So first characteristic is about of matter is there is spaces between the particles of matter. This is the first characteristic. Whereas going to second one, they are continuously moving. If I take a gas, or if I take gas, if I take oxygen, O2, these O2 molecules, or we call it particles. Particles of O2 is also like hydrogen, but they're continuous moving. In solid, we does not much we can see the moving of this particles, but it definitely happens. If we take O2 particles, they're continuously moving, continuously. These gas particles are continuously moving. Means the particles of matter are continuously moving. Nextly, attraction. So in solids we can see this more. If I talk about this solid means I will talk it about later. So solids in solids we see much amount of attraction. Attraction means how can a solid be fixed like that? Means it will be stable in a definite shape. How will it be like that? Because of this attraction calcium means the particles of matter. These particles of matter is there attract to each other means bind. This attraction it attract it. I mean there is attraction between particles of matter. Then only we can see a solid structure. Alright. These are the three characteristics of matter. So now we can see that the moving takes place. So an important thing about moving is diffusion. So let's talk about that. Now let's try to write definition for diffusion, guys. So this diffusion is a very interesting topic. I know. You know that second classic, the particles of matter are continuously moving. All right. So based on that, why they are continuously moving to form diffusion? The diffusion, it's a specific phenomena takes place. If you gonna see that, firstly I'm gonna tell you some experiment about diffusion. You're gonna spray bottle. You had a scent bottle which is smelling so nice. So if you spray it, if you the it all spreadly to far place. I mean, what the media places to you, it definitely will be smelled to another person. I mean, it a diffusion, it intermixing of particles in the air. Firstly, I don't want to go for definition. I want to explain it in a simple way to understand much better. So the intermixing of particles in the air is called diffusion. But in definition form, I will tell you how to write. Passage of gases from an area of high concentration area to low concentration area. This is the simple definition for diffusion, guys. So you're gonna observe that passage of gases from an area of high concentration area to low concentration area. Alright, what is high concentration area? What is low concentration area? If you're gonna observe that, I tell you a simple example for this. If you add a water in a large amount in a big tumbler or big vessel, so we had another I mean it's fully water is there in this vessel. When in this the half filled, I will try to be near to this. This is half filled water, not as much like this. This is fully filled, but where I'm going to this is halfly filled. The beaker is there. So if you're gonna observe that, if you're gonna join, if I go and join this, I want to explain in a practical way, so I am telling this about this experiment. It's not an actually experiment, but it is an example I will tell you. So this water, definitely where to where the water can travel. If this water is small amount of water can carry, or this, I mean what I'm telling, these two vessels are joined with a pipe here. All right, this water already been like here like that. All right, you already been outside means greater than this pipe. This water level is been there. It's lower, not actually there. So I'm joined this two big. Definitely, the what is the higher amount of water can travel to this lower beaker from this path. That water can travel to this and settle in this beaker. So by this experiment, what you conclude? Anything, not only this water, I'm telling it is an example only. So passage of gases also. These gases also travel from an area of high concentration means high amount you can tell. So high amount to low amount. So passage of gases from an area of high concentration area to from an area of low concentration area. This is all about diffusion, which is a very important topic you have to note down. Alright. So now let's learn about the states of matter. Now let's discuss about three states of matter. It's mainly solids, liquids, and gases. So solids and liquids and gases. So in this matter is divided into mainly three states. These are solids, liquids, and gases. And I know that you had an idea about these three, but we have an idea deeper in this video. So about solids is they had firstly if we talk about their shape, it has a definite shape. It's a fixed shape it has. So definite shape. Alright, definite shape is there. And next we are going to liquids. It does not have a fixed shape. If you take a rectangular shape water vessel and another it should be in a triangular form. Alright, if you keep this water in a triangular vessel, it will be formed like a triangle. If you keep that as same water in that triangular beaker, you're gonna form a triangle structure. So what we conclude by this experiment, the liquid does not have a fixed shape. It will be changing its shape forever. It's all over things so on. So no definite shape. Alright, this one is also here. And one thing is very important. What I wrote down on the board, have to note down in your notebook. It's very important. It's a good habit also. So don't forget this one. And about gases, it also don't have any fixed shape. You're gonna see that air. This air does not have a fixed shape. So no, here it's also no. This one also you have to write here only. It's alright. Let's see. Both sides. If we talk about volume means the how much matter is will be there in that. I mean, how can I say it? Is because you take about liquids. If you take 1 liter of water, say I will carry in this bottle 1 liter of water. So that is the what is the magnitude? What is the number is there 1 liter? So we call it as that value. I mean, what is the amount is present in each of this in each of the states. So that we consider as value. So let's have a fixed value. All right, we all know that fixed value. Next point. Note down this point. Fixed volume is there. And about liquids, yeah, of course, liquids also a fixed value. I carry 1 liter of water. I carry 2 liter of water. This tank capacity it can hold up to 500 liters of water. So here, likewise, what we conclude is liquids also have a fixed value. Alright. So yes, here you can write here also. I'm telling just to mark. And about gases. If you consider about gases, it does not have any fixed value. Alright, because you can observe more spaces between particles of matter of gases. So how can we able to define this value, this value? So they are continuously moving. So the value also can definitely change. So no fixed value is there. And nextly, if we talk about compressibility, it is very important if you know down. So compressibility. Compressibility means compressing compressing means converting high value to low value by compressing by applying pressure, that is called compressibility. So we have to write down in definition 3. And alright, now what we can see here is these three states which are compressible, which are not. Let's see, solids are not actually as liquids and gases, not actually as liquids and gases, but much amount they can be, but David does not observe it. So yes, but not as, yes, not as, yes, but not as gas. Alright, whereas gases are compressible. They are very very compressible. So I'm writing they are compressible. Compressible. You had observed that LPG, liquefied gas, is the cylinders, gas cylinders for cooking we use in our homes. So that is made by the term phenomena compressibility only. That gas is there, they compress it to form liquid. So that liquid cylinders we get and we used as a gas. Alright, this technique is used in the manufacturing of cylinders which are used for cooking. So they are compressible. This is very very important. Note the term compressibility. All right. Now let's see some facts about simple liquids and gases are about. So solids have less spaces between them. Liquids are more compared to solids, and gases more compared to liquids and gas. So solids. All right. What about attraction? Attraction is more in the solid, and liquids gases some less only. And diffusion, I mean the continuous moving of particles. The movement of continuously movement of particles is observed in gases, so not in liquids that much, but solids okay, alright. Solids also not be observed as much as liquid. So now let's learn about density also. Alright, density is also one of the topic. You know what do you mean by density? We measure the density per unit area. If this topic is very deeply, you can learn in further classes. But I'm telling somewhat introduction about this density topic. What do you find in this density topic is per unit area. If you wanna take an example, if we have water, some objects can sink, some objects can float. Alright, this is happening due to density only. So density formula I'm telling mass by volume. So here what point we have like is where is solid density is more. In the place of the states of matter, solid density is more than liquid, whereas liquid density is more than gases. Alright, like this. Solid density is more than liquid density is more than gas. For this topic I am telling about density. Alright. And another thing what we learn in this chapter is about the interconversion of matter we had discussed. Now let's see about interconversion of matter. It's a very very important topic in this lesson. Interconversion of matter. In this topic, interconversion of matter, we're gonna observe. We had already had three states: solid, liquid, and gas. So in these three topics, we're gonna observe how the interconversion takes place. What we call that? If we convert this solid to liquid, we call it as fusion. So I'm telling about the definition of fusion. The interconversion of the solid to liquid state we call it as fusion. When we convert this liquid into gas, we call it as vaporization. Alright, note this suffix vaporization. And if we convert this gas into liquid, is called condensation. And if we convert this liquid into solid, it's called solidification. I'm telling these all definitions in a mind mapping way because you can easily memorize and understand it. So, if we convert this solid directly into gases, this is called sublimation. sublimation. So what we are converting solid, we directly converting into gas, not by converting into liquid. Alright, we convert this gas directly into solid, we call it as deposition. Deposition. Alright, these are the topics you have to learn. And next, what I am telling is about melting point and latent heat of fusion. Alright, if we take a glass tumbler, I put it 1 kg of ice. What I'm putting 1 kg of ice, and I'm burning it by the help of a burner. If they are sometimes they convert it into liquid. All right. So here, what do you have to understand is what do you mean by melting point? Wrote the definition in your notebook. I'm telling what is the definition. All right. Clearly, you have to listen. All right. So melting point definition means the heat energy required by 1 kg of solid, means 1 kg of ice, I am telling 1 kg of solid to convert into liquid form, at atmospheric pressure, we call it as melting point. Melting point. Alright. And next term in this is melting point of ice is 0 degrees Celsius. Alright. So what we are converting ice into liquid form, where at melting point. Melting point is 0 degrees Celsius. Alright. I think you had a clarity about this. And latent heat of fusion. Latent heat of fusion. So for this definition I am telling, it's very important you to note down. Alright, latent heat of what is fusion? We are telling fusion only. We converting a solid into liquid. So I am calling it as fusion. Alright. So fusion. The heat energy required by 1 kg solid to convert into liquid at its melting point, we call it as latent heat of vaporization. Sorry, latent heat of fusion. So, you can repeat that video and note down that definition. So, what I am telling in the definition is the heat energy required. What is the heat you have to apply to convert this solid into liquid at its melting point? What is a melting point? I think it's 0 degrees Celsius. Means ice is in minus Celsius. About 0 degrees it will form, alright. And like this, I am telling I will take 1 kg of liquid. I mean about 1 liter, alright. If I take that much of liquid in this beaker, same beaker, I will heat up it. So what happened? This liquid, what is the liquid state can convert it into gaseous form. Means vapor will form. Means this liquid can will be converted into vapor form. So what we call this melt, it does not, it's a melting point. It's a boiling point. Boiling point. First experiment is over where we are converting solid into liquid. Here now what we are discussing, liquid into gaseous state. Alright. In this state we talk about boiling point. Alright. Boiling point is 100 degrees Celsius to convert water into liquid. Alright. Boiling point. The heat energy required by 1 kg of liquid, 1 liter of liquid to convert into its vapor state at its boiling point, at atmospheric pressure we call it as not boiling point, at atmospheric pressure we call it as boiling point, and latent heat of fusion converted into latent heat of vaporization, because we are doing vaporization. Liquid into gas we call it as vaporization. Vaporization. So latent heat of vaporization, note this definition firstly. Latent heat of vaporization means the heat energy required by that amount of liquid to convert into its vapor state at its boiling point. We call it as latent heat of vaporization. This is all about the whole lesson. And in this lesson, another thing is that evaporation. So you all know that evaporation takes place below the boiling point. Below boiling point, the evaporation takes place. Evaporation means the converting of liquid state to vapor state, the vapor in form. So what is important here is about what is important in this evaporation topic is factors affecting evaporation. What are the factors affecting evaporation is very, very important here. So let's learn about them. Firstly, area, surface area. So factors affecting evaporation is firstly surface area. Surface area. I mean, if I take an example that it is a beaker and it is a small beaker. I take 5 ml of water here, 5 ml of water here. 5 ml, 5 ml. So what you wanna observe, if I keep it on sun for heating, alright, these evaporate fastly. I mean, they convert it into vapor fastly compared to this one. Why? Because here itself 5 ml of water, here itself 5 ml of water only. So if you wanna observe that vessel, the size is different here. This is very long and it's very comfortable, but it is very small. Alright. So high amount it will be upper side. The bowl will also covered with water. But here it will they will be flatly surfaced. So that surface area will also decide the amount of evaporation and the time for evaporation. Alright. Next is humidity. What do you mean by humidity means? The amount of presence of vapor in water, a vapor in the air, or presence of vapor in the air is called humidity. So what I'm telling is, if humidity is very more, then the evaporation takes place less. Evaporation takes place less. Why? Because humidity is always is already in the air. So how evaporation takes place? Alright. Nextly, the third factor is wind, which is there. These two are interrelated because if wind blow, that humidity gone far away. Alright, if wind blow, that humidity gone far away. Then evaporation, then humidity decreases. Then humidity decreases, evaporation increases. Then observe if your cloth, your wet cloths are being hanged out on the environment on the outer side. If you wanna observe that, if the humidity not present, if wind blow, they can easily dry up. So this is what is about even these three are factors: surface area, humidity. The factor is temperature also. The temperature is also one of the factor of this evaporation because if temperature increases, if sunny, in a sunny day the cloths will dry very fastly because of temperature. If in sunny day temperature is very high, so the evaporation takes place is also very high. By that only your clothes are dried easily where compared to rainy season in summer season because of sun where temperature increases in summer season, right? So these are the factors affecting evaporation. These topics are very very important. I will clearly mention all those concepts in a simple and easier way. So all the whole chapter I covered in this small time. I mean, in this time I will come to learn all those topics because in less time we can learn such a more topics in a simpler and easiest way. So what I am telling is for more videos like interesting videos like this in one shot and rapid fire we are learning. So for more videos like this, subscribe to our channel Harshit Academy and like share this video to your friends and everyone also. So this is very helpful and what you want classes, what you are interested in. So that classes you also tell in comment section. Alright, see you in the next video.